It appears as a bright orange star among the thousands of stars in the night sky. But in reality, that orange star is actually the planet Mars. At its closest approach, it sits 54 million kilometers from Earth. Mars is approximately half the diameter of Earth, with a surface area only slightly less than the total area of Earth's dry land. Yet it appears so small. Hop aboard the shuttle Astr0Nick, and let's travel to our nearest planetary neighbor. Often referred to as the red planet because of the reddish iron oxide prevalent in its surface, Mars is distinctive among astronomical bodies visible to the naked eye. Mars is a terrestrial planet with a thin atmosphere, having surface features reminiscent of both impact craters of the Moon and the valleys, deserts, and polar ice caps of Earth. Mars is the fourth planet from the Sun and is anywhere from 54 million to 401 million kilometers from the Earth, depending on the time of the year. The Martian terrain is very similar to Earth due to the volcanic activity, which plays a significant role in Mars's geology. Thanks to an Earth-like terrain, humanity has been able to send rovers and landers to Mars to collect data to help us understand our planetary neighbor a little better. Since 1976, NASA has successfully landed 8 landers and rovers. Mars is the only planet in our solar system that is inhabited entirely by robots. These robots have had great success in discoveries such as water and minerals. The Curiosity rover landed in August of 2012. It has explored the Martian terrain, dug dozens of holes for soil samples, and has provided us with a wonderful view of what the surface would look like compared to ours on Earth. NASA's InSight lander became the latest robot on Mars. InSight will place a seismometer on the surface of Mars to measure seismic activity and provide an accurate 3D model of the planet's interior and measure internal heat flow using a heat probe called HP3 to study Mars's early geological evolution. This could bring a brand new understanding of how the solar system's terrestrial planets form and evolve. Over the course of our exploration of Mars, we have successfully landed 8 rovers. All of them study different things about Mars and play a vital role of our understanding of the Martian surface. Using argon as a tracer of atmospheric dynamics, the Sphere and Opportunity rovers employed their APXS instrument to measure the atmosphere of Mars and detect argon. The same 2 rovers also studied the dust frequencies and the dynamics, showing how dust and sand are moved by wind in Mars's very thin atmosphere. The Opportunity rover has found evidence that ancient Mars may have been habitable for millions of years. At the rim of the Endeavour crater, the rover discovered ferric and aluminous smectite clays in finely layered rock formations that pre-existed the Endeavour impact event. These are the oldest rocks examined by the Opportunity, roughly 4 billion years old, and they were exposed to waters much more habitable than the waters that led to the Burns Formation. Aside from using telescopes from Earth, the rovers and landers on Mars have helped us in a great deal in gaining knowledge about the planet. And because of this, we know about its important characteristics. Researchers at NASA's Jet Propulsion Laboratory have analyzed 3 years of radio tracking data and have concluded that Mars has not cooled to a completely solid iron core. Rather, its interior is made up of either a completely liquid core or a liquid outer core with a solid inner core. In addition to the detection of a liquid core from Mars, the results indicate that the size of the core is about 1/2 of the size of the planet, as is the case for Earth and Venus, and that the core has a significant fraction of a lighter element such as sulfur. NASA scientists have found evidence that Mars's crust is not as dense as previously thought, a clue that could help researchers better understand the red planet's interior structure and evolution. A lower density likely means that at least part of Mars's crust is relatively porous. At this point, however, the team cannot rule out the possibility of a different mineral composition, or perhaps a thinner crust. NASA's Curiosity rover discovered unambiguously fluvial sediments on Mars. The property of the pebbles in these outcrops suggested former vigorous flow on a stream bed, with flow between ankle and waist deep. These rocks were found at the foot of an alluvial fan system descending from the crater wall which had been previously identified from orbit. A rock outcrop on Mars was compared with a terrestrial fluvial conglomerate from Earth, suggesting that water once vigorously flowed in a stream on Mars. The idea of water on Mars has preceded the space age by hundreds of years. Early astronomers correctly assumed that the white polar caps and clouds were indications of water's presence. Many astronomers were refining the tool of planetary spectroscopy in hopes of determining composition of the Martian atmosphere. Between 1925 and 1943, Walter Adams and Theodore Dunham at the Mount Wilson Observatory tried to identify oxygen and water vapor in the Martian atmosphere, but unfortunately, they could not identify it. Only carbon dioxide was known to be present in the Martian atmosphere. Water vapor was not detected on Mars until 1963. On November 4, 2018, geologists presented evidence based on studies in Gale Crater by the Curiosity rover, and that there was plenty of water on early Mars. Analysis using rover's DAN instrument provided evidence of subsurface water amounting to as much as 4% water content down to a depth of about 2 feet in the rover's traverse from Bradbury Landing to the Yellowknife Bay. Dating back to December 2012, NASA reported that the Curiosity rover performed its first extensive soil analysis, revealing the presence of water molecules, sulfur, and chlorine in the Martian soil. And in March 2013, NASA reported evidence of mineral hydration, likely hydrated calcium sulfite in several rock samples, including the broken fragments of Tintia rock and the Sutton Inlier rock, as well as veins and nodules in other rocks like Nor rock and Wernickel rock. NASA reported detecting an unusual increase, then decrease in the amounts of methane in the atmosphere of the planet. In addition, organic chemicals were detected in powder drilled from a rock by Curiosity. Also, based on deuterium to hydrogen ratio studies, much of the water at Gale Crater on Mars was found to have been lost during ancient times. The Curiosity rover played a vital role in helping us learn about Mars, and each time we send a new rover, we learn just how Earth-like Mars really is. Could you just imagine yourself here? As NASA prepares more rover missions to Mars, each mission is going to help us gain a little bit more knowledge on what we need to do before we can send humans to Mars. NASA aims to have humans on Mars by the 2030s, but there are some challenges we have to overcome in order to make this a reality. First of all, how do we keep the astronauts healthy? On Earth, tiny gyroscopes in your brain give you spatial awareness. They tell you when to tilt your head, accelerate, or even change position. But it's a little different in space. In zero gravity, those gyroscopes don't work well, and it causes the body to become nauseous all the time, kind of like being seasick. We have to worry about space sickness, weaker muscles, eye problems, colds. Once we have all the health issues out of the way, then what about the time that it actually takes to travel to Mars? A trip to Mars might take nearly a year and a huge amount of fuel. The chemical engines used to launch a rocket into space with a fiery blast are not good at propelling a spacecraft to another planet. With no gas stations between here and Mars, you pretty much have to take all your fuel with you. So the best travel tactic would be to use what is called the Hohmann transfer orbit. The Hohmann transfer orbit is an elliptical orbit used to transfer between two circular orbits of different radii in the same plane. A mission to Mars using the Hohmann transfer involves an approximately 9-month travel time from Earth to Mars. Once in Mars's orbit, the astronauts will have to safely land at their landing site. After landing, the crew will need to construct a Mars base. Our imaginations wander on what a Mars base would look like, and Hollywood and science fiction have molded our minds to picture what their Mars base would look like, but it may not be as exciting as one would think. It would perhaps look more like a biosphere. We long for sending humans to another planet, and as long as there's interest in exploring space and looking for the next frontier, Mars will continue to be the planet that we have the most interest in. Next to Earth, of course. Until next time, be curious, be creative, and always look up.